All right, so after we broke down section 6-2 into 3 different days, we're going to dive in and make sure we tackle 6-3 sums of radicals, and there's no pre-lesson. Why? Well, you'll see. Here's a quick review. We're looking for like terms here. Okay, that's the old pre-algebra algebra term. What's 5x minus 2x? 3x. What's 3y minus 1y? 2y. Adding like terms. Now you've got combining radicals. The word like radicals should probably be in there. But here you have 5 square root of 2 minus 2 square root of 2. That would give us 3 square root of 2. Now you've got 3 square root of 3 minus 1. There's an invisible 1 there. 3 square root of 3 minus 1 square root of 3 would be positive 2 square root of 3. And you can't go any farther. This is like 3 bananas plus 2 apples. No, we're not talking blenders. You got 3 square root of 2 plus 2 square root of 3. These are not like terms, so you can't keep going. So, what did 6-2 have to do with any of this? You'll see. So the first thing we have to do is look at these and ask ourselves, are these simplified? And see that square root of 8 can be the square root of 4 square root of 2, which is 2 square root of 2, plus, and see, voila. As you can see, you're going to have to break stuff down and then look for like terms. So I have 2 bananas plus 2 bananas gives me 4 bananas. All right, there you go. Now I know there's been a lot of talk of like when you square a square root, the roots fly off. That's true. But we're just adding like terms. So this is just like 2x plus 2x is 4x. See, that part doesn't change. Okay, so this is simplified. Square root of 27 can be the square root of 9 square root of 3, which is 3 square root of 3. Square root of 300 can be the square root of 100 times the square root of 3, which would be 10 square root of 3. Now I've got 1 banana plus 3 bananas plus 10 bananas. Those give me 14 bananas. Done. Let's go to this one. Here we got some oil. We got some water. Don't you dare make this the square root of 54. So we go 2. I'm going to break down the square root of 27. Square root of 9 and 3, which is 2 times 3 times the square root of 3, which is 6 square root of 3. Okay, we're done with that one. Square root of 12. That should just be the square root of 4 and the square root of 3, which is pretty easy. So that's just plus 2 square root of 3 minus, I'm just going to go ahead and drop that minus down here. And then the square root of 75 is the square root of 25 and the square root of 3. If this number isn't just popping into your head, you'll get better at it. That'll just take time. So the square root of 25 is 5 square root of 3. Now I go on the hunt for like terms, and I got them. So I'm going to add these together. I got 8 square root of 3 minus 5 square root of 3. 8 minus 5 is just 3 square root of 3. All right, they're going to get a little different, a little bit more challenging. And here we go. The cubic root of 250, that would break down to 125 and 2. Might as well clean this up to 5 cubic root of 2. Minus, because I can see that subtraction, cubic root of 54 breaks down to the cubic root of 27, cubic root of 2. What's the cubic root of 27? That's 3 cubic root of 2. And then this guy is just challenging you, I think, to see if you're too conditioned. You know, the square root of 4 is 2. But that's not a perfect cubic root, and it's just kind of stuck. It's just sitting there. It's like a test. See if you'll do something with it when you can't. And here's my like terms in the box. 5 bananas minus 3 bananas. 2 bananas plus 1 apple. Done. Nothing you can do with that. Now example 5 looks intimidating at first, but notice Square root of 4, square root of 4, gotta love it. So this just turns into the square root of 3 all over 2. Now, I know it's plus, and I know that that square root of 4 is also 2, but I'm going to go ahead off to the side. I'm going to make that square root of 9 square root of 3, which would give me 3 square root of 3 from here to here. Now look at it. We got common denominators, which means we can add the numerators. Don't forget, simple stuff. 1/7 plus 1/7. Doesn't that just equal 2/7? So you add the stuff in the numerator, you leave the denominator alone. So this would be 1 square root of 3 plus 3 square root of 3, which would be 4 square root of 3. Leave the denominator alone, and you're like, whoa, wait a minute, that can reduce, and you're right, 2 square root of 3. Now, notice, we took the square root of 4, took the square root of 4, and it was just nice. We got common denominators. Let your eyes wander over here. This one's going to be a little nasty. Now, I used to teach example 6 a certain way, and then students just said, no, why don't you just show students this way? They'll like it better. So here's the way students have taught me how to teach you. So they see the square root of 3, and they see the square root of 5, and they're thinking, hey, common denominator is going to be the square root of 15 plus the square root of 15. And I like it. So those students have taught me that, hey, just take this one, multiply this by the square root of 5, square root of 5. Notice we're not worried about getting the radical out of the denominator right now. We're just trying to get common denominators. And look what happens. We end up getting square root of 5, square root of 5 is the square root of 25, which is just 5, over the square root of 15. Now we're going to do the same thing to this, same-ish, square root of 3, square root of 5. On this one, we need common denominator, so it's got to be square root of 3, square root of 3. So if we multiplied straight across here, we'd get 3 over the square root of 15. And we go, wait a minute, we got common denominators. Remember my point over here? You don't change the denominator. So this would just be, I know this is getting messy, but 5 plus 3 is 8, so we get 8 over the square root of 15. Now, a golden rule in algebra and parenting, don't leave radicals in your basement. So now we're going to get rid of that. So oil and water, so those do not mix. When you square a square root, the roofs fly off. And you can't reduce this, so we're done. Yeah, that one's a little nasty, no doubt about it. All right, got quite a few on the backside. Now, I'm not trying to be lazy. I'm just being honest. 7 and 8 are just the same. They really are. So I'm just going to do one of them. I'll pick the second one. So we're going to multiply these together. Notice oil, oil. So those can mix mathematically. Water, water. And then I got to take this negative 4 square root of 6 and multiply it by this negative 5 square root of 3. So first of all, a negative times a negative is positive. 4 times 5 is 20. 6 times 3 is 18. You see, these aren't too bad. And I'm just going to break this down. So negative 12 square root of 4 square root of 3, which is negative 12 times 2 times the square root of 3, which is negative 24 square root of 3. Now I'm going to do the same thing with this one. So I get 20 square root of 9 square root of 2, which is 20 times 3 times the square root of 2. 20 times 3 is 60 square root of 2. And guess what? Apples, bananas. You can't go any farther because those are not like terms. All right, example 9 and 10 are very similar. So I might do both of them, but I want to show you guys something first. 10 plus 2 over 2. If I was to say to you, hey, try this, I know you would go 12 over 2 and you would get 6. But if we went a little different way and we thought, hey, let's go this way, break that up into a fraction, go this way, break that up into a fraction, and reduce those, we'd get 10 over 2, which is 5, 2 over 2, which is 1, 5 plus 1 is, yep, you guessed it, 6. You know what that means? Going this way is 100% good. Why would I show this way? because of problems like this. Notice we cannot add the square root of 21 plus the square root of 15. These are not like terms. And notice they're kind of baiting you into trying it, because if you did, you'd get the square root of 36, and you're like, hey, that works out. Can't do it, because these are not like terms. So that means we have to go this way. And notice, this is water and water. See, if you guys looked at 21 over 3, I know you'd be able to go, hey, that's 7. So what I need you guys to do is think square root of 21 over the square root of 3. That just spits out the square root of 7. And then we go this way. What's the square root of 15 over the square root of 3? Square root of 5. Done. So because they don't take very long, let's just go this way. So this here would just spit out the square root of 3. Here, don't forget the minus the square root of 12. Not done, because this breaks down into the square root of 4 and square root of 3, which is 2 square root of 3. So really this problem turns into the square root of 3 minus 2 square root of 3. There is an invisible 1 here. So 1 square root of 3 minus 2 square root of 3 is negative 1 square root of 3. And a student could just write it like this. Either way is fine. Okay, last problem. This is clearly asking us, just like example 8, to distribute. So we're going to do that. However, I always say, look for the Christmas gifts. Do you see any? I see 2 of them. Square root of 9, well, 3 of them. Square root of 4 and square root of x to the 4th. And if you don't notice those, I think you're just going to make your life miserable. So we're going to bring that down. We're going to make a small adjustment. Square root of 9 is 3. That x is still trapped. Minus square root of 4 is 2. And remember, square root of x to the 4th. Remember how to do these? You just take that over. That goes in the numerator. The index goes in the denominator, and that would just be x squared. And now, look at it. We got some oil here, and this is all oil. This is water. This is water. So when we multiply, you can mix the water and the water. So when we multiply, let me get out my pretty colors. When we multiply this by this, we would get 3 square root of 2 x times x is x squared. We'll get back to that in a minute. But then when we multiply this by this, there's really nothing that mixes. So we're going to put that in front, minus 2x squared square root of 2x. Now, very tempted to be done. Problem is, look at this, the square root of x squared. That's just x. So the x is going to pop out. It's going to be 3x square root of 2. There's nothing to do here. So we're done. See, they're going to make these problems a little bit nasty. You just got to hang tough. All right, good luck on that assignment. 6-3.